First, I will give you an introduction about the facility I work in. We have two irradiators, one industrial plant used to irradiate industrial products. Oh, okay now. Good. Okay. And the other one is research one. The irradiation chamber volume is 4 liters, so it suits all specimens for research, whatever the purpose. This is the industrial facility. You see top right, the boxes where we put the products to be irradiated, and top left is inside the irradiation room, and down right. And the other picture shows the outside of the facility. Maybe some of you know about this technology, the irradiation. We irradiate the products in order to sterile, to kill the microbes on these products. Some products need to be sterile. Sterile in the medical expression means zero anti microbes, and some products need to be pasteurized just to reduce the amount of total bacterial count to a certain limit that complies with the standards. So for healthcare products, everybody use the eyedropper. So this eyedropper should be sterile because the human eye is very sensitive, so any contamination will be affected. And the second product, the blood lines used for kidney washing, also these should be sterilized because it is in contact, direct contact with the human blood. Anything with direct human blood or fluids contact need to be sterile because any bacterial count will cause infection to the human. Also, we irradiate the petri dishes, the blood collection tubes, and urine cups when you go to the laboratory to test your blood or urine. These kind of soups where they collect the blood in should be sterilized also or pasteurized. Also, the plastic pipets for planting for pregnancy. All medical instruments that be used in surgery in the human body should be sterile because it is direct contact with the blood or fluids of the human. This plastic pipettes for pregnancy is very sophisticated kind of product and it should be sterilized. Also, the surgical gowns used in the surgery room also should be pasteurized or sterilized. Also, this is for healthcare products. The other products that categorization is healthcare, pharmaceutical products. For example, the empty gelatinic capsules that we use to take is also pasteurized. Uh, uh, the filled gelatin capsules with herbs for pharmaceuticals. When you drink a cough syrup, there are some kind of herbs inside, so these herbs should be sterilized, and the honey used also in syrup for children or adults, these also sterilized. Veterinary products also, and veterinary containers also can be sterilized. Food. Generally in Jordan, we are allowed to irradiate spices, herbs, and nuts, but generally worldwide, Far East, North America, South America, but only Europe. They don't apply or accept to irradiate food as designation, like meat, fish, and other products of food. Also, we irradiate cosmetics. In Jordan, there is a sea that is we call dead because no life in this sea because the salinity is about 27%. So the mud comes out from this sea is good for cosmetics and it should be irradiated because it contains a huge amount of bacteria that lives in salt media. Also, some products that are ingredients in the cosmetics like calcium carbonate, bentonite, and the talc powder. In the Gamma Research Irradiator, we implement a lot of research and investigate the effect of radiation on the new products so that we can determine the needed dose that enough to reach the bacterial level that's accepted by the standards and the needed dose that will not affect the properties of the material to be irradiated. This is the research irradiator. On the left, you see the 3 bars where we put the specimen and irradiate the product. Generally, yesterday and today, I heard a lot about how to make a new product by using the chemical reaction. In our case, we don't go through these complicated reactions. We only irradiate the finished product to get the benefit of that. Actually, we are using the Cobalt 60 that emits gamma radiation, and this gamma radiation has 2 photons, 1.3, 1.2 MeV, and this amount of energy is capable to break the chain in the organic molecules, break one chain or make another chain, so it can break or make degradation or cross-linking. So by degradation, we can simplify the product. By cross-linking, maybe we can improve the mechanical properties of the product. Generally, some applications like the health care products, it's worldwide use the radiation, electron beam or gamma radiation or X-ray radiation to sterilize these products. But in case of improving the properties of some products, like the plastic pipes. Plastic pipes can be irradiated by electron beam, and after irradiation, it becomes like stainless steel, very hard and tough, and the melting point is very high. No need to go through the complicated chemical reactions. It is an option, and nowadays it is worldwide used in European, North American countries, in China, Far East. Also, there are some applications for what I heard from the researchers yesterday or today about the improving the semiconductors by radiation, removing the pigments and dyes by radiation, and these are the products that we irradiated. On the top right, the eyedropper dialysis bloodline, plastic pipes for planting, for pregnancy, and the urine containers, petri dishes, empty gelatinic capsules, and blood collection tubes. This is according to our investigation on these products. These are the variety of polymers that to be irradiated, and the needed dose and the effect, and the for example, the polycarbonate for pipettes needs a 25 kilogram sterilization dose. The resistance for gamma is good, but there are some color change. Generally, researchers always using the pure polymer, but in practice there is no pure polymer. Because industry they use plastic, they use stabilizers, plasticizers, flame retardants, UV stabilizers, colorants, pigments, antistatics, agents, and the most important is the fillers, because sometimes the polymer is very expensive, so they put some kind of filler to reduce the cost. And reinforcements, in which the color changes tolerates. These additives will affect the mechanical properties, and the color of the finished product. I think that there is no radiation facility in Algeria. Researchers here in Algeria could push the things forward so that there will be a radiation facility which serves the industry, serves the researchers, and there is a very good benefit from that, because the nearest radiation facility is in Tunisia, which is far away from the industry or researchers here in Algeria. And I heard a lot of Jordanian investors cost sharing with Algerian producers, made a lot of factories here in Algeria, and they need the radiation technology. For example, there is a petri dish producer under the name SAR Diagose, and they are suffering because there is no radiation facility. In the production, you can improve your production line so that you don't need sterilization after, but these additives to the production line cost a lot of money, which affect the final product. There is also a lot of supplement manufacturing companies here in Tunisia, in Algeria, sorry. They irradiate the raw herbs in Jordan, then transport these herbs to Algeria, and they fill it and they produce the supplements. I think introducing a new gamma, E-beam, or X-ray facility in Algeria will improve the national industry in making Algerian products competitive and facilitate the recognized research activities in universities and petroleum industries, and open the way to new radiation application in health, agriculture, and environment. In our facility, we are willing to cooperate to the maximum with the Algerian researchers or producers in providing gamma radiation services. In Jordan, we have a lot of researchers from Palestine, Iraq, and Lebanon. The neighboring Arabic countries, they got benefit from the existence of radiation technology, so they implement their research. One important thing in our work, when somebody came to irradiate any new product, there are two things to be in concern. The first, what is the level of microbial bioburden accepted? If it is 0 or 110 CFU. So according to the original microbial contamination and the needed microbial contamination, we can decide or expect the range of dose that needed for this product to be irradiated. But the problem is that these products are mainly made of polymer, and this polymer will be affected by radiation. So we have to decide the dose in a way that it should exceed the limit of killing the bioburden, but does not exceed the limit that will affect the properties of the polymer. For example, in syringes, the transparency is a functional. So if the effect is coloring so that the color become very dark, it's not accepted. So the dose should be reduced, or the polymer should be changed to another polymer that the transparency does not affect it. Generally, every new product, we made a research in this regard, microbial research and analysis of the effect of radiation on the polymer. So one of the polymers that we irradiate a huge number, millions per year, is the Petri dishes used in the microbiology lab. So we share, as you see, I am introducing this presentation on behalf of my colleagues, Dr. Mustafa Qasi from Algeria, Dr. Amira Zaouk from Tunisia, and Muayyad Sufyan from one of Jordan universities, and my colleague, Dr. Anas Al-Wahiba. He's working in our facility, and me. So the objective of this research was to analyze the effect of overexposure of gamma irradiation of polyester on chemical optical properties at various exposure times. The samples were characterized by means of the FTIR and the ultraviolet visible spectrophotometry. These samples irradiated in the research irradiator at a dose rate 3.2 kilogram per hour in gamma radiation. The samples were irradiated in the presence of relative humidity 46% to doses 20, 40, 70, 95, in addition to the control sample. Also, it is the samples in the presence of air mean the effect of oxidation will be considered. The material information for this kind of polyester that used in the Petri dishes, the manufacturer is El Hanouf Medical Labs Factory, AFCO. The product is a disposable after the microbiology test. This Petri dishes is disposed. The polystyrene type is general purpose polystyrene, commonly used for medical grade disposables. The molecular weight is between 200,000, 300,000 gram per mole, and the density from 1.04 to 1.06 gram per centimeter cube. Additive content, presumed additive free, no added, no added materials, so it would be suitable for medical applications. The appearance for the Petri dish is transparent. This is the main functional property for the Petri dish, and it should be rigid, but it is brittle, typical to unmodified general purpose polyester. So this is the IR spectrum for the different doses. You see that the first thing to be affected by the radiation is the benzene ring. So it start to disappear from the first dose at 20 kilogray and continue to disappear. Maybe it is broken or become not side branch, become in the main linearity of the product. Also, the OH starts to disappear after the dose 40. Also, the ACH affected little bit as the dose increases. This is the mechanical testing for the specimen. As you see, the hardness and the tensile strength, elongation, the toughness increase and decrease according to the changing in the molecular weight of the polyester. And the color change is very obvious by the eye. On the left the 0, and you see at the right the 95 kilogray. So the change in color appears by eye. And if we take the part of spectrophotometry in the range of 270 to 390, it is obvious that the difference becomes very obvious. And these are the references. Actually, regarding the transparency, still at a dose of 95, it is still transparent, but our concern was not to exceed 30 kilogray at that range where they might the dose reach in the real operation conditions. And thank you.